Good day everyone, I'm Harris Badwa and I'll be discussing CALENG2 for long quiz number 2. Now this long quiz will comprise of the following topics, which includes integration by parts, trigonometric integrals, trigonometric substitution, rationalizing substitution, rational functions, and improper integrals. Now as a short review, we'll briefly discuss about these following topics. Now that we're done with our second problem, let's move on to the third one. We have another indefinite integral. This one, the upper limit is 5 and the lower limit is 3. So our numerator will have 4dx all over x cubed minus 2x squared. We can rewrite this integral like this. We can factor the denominator by x squared, which means that we'll be left with x minus 2. And this is 4dx. And looking here, it seems like we can't do anything else. But if you remember from our F&D math classes, we can actually use the partial fraction decomposition and integrate that function. So first is, let's rewrite here. Let's write the function here. 1 over x squared, x minus 2. We'll equate it to a over x. Let's write the repeating variables first. And b over x squared plus c x plus 2. And down here, we'll just combine these three into one term. And their denominator will be x squared times x minus 2. And here we'll have x times x minus 2 multiplied by a. Since this one, makakancel lang ito. Makakancel lang yung squared, pero i-multiply pa rin itong denominator to a. Plus b. Since we have x squared, we don't have to multiply it by x squared. Ang matitira lang is x plus 2. And for c, ang matitira is x squared since meron na tayong x minus 2 here. This one is x minus 2. So this one was x squared c since na-cancel na yung x minus 2. And here we'll just copy this one. 1 over x squared x minus 2. So we'll just distribute the following function, which will give us x squared a minus 2xa plus bx minus 2b plus x squared c. Then this will be, this is 4. Forgot, this is 4. This is 4. And since we have the same denominator from both sides, we can actually cancel that na. So we'll be left with all the denominators. Now here, for the right side, as a review, once you've distributed all the x's, we have to combine like terms with respect to x. Which means that x squared will be grouped together, x will be grouped together, and those without x will be grouped together. For here, we'll have x squared a plus x squared c plus bx minus 2xa minus 2b. This is still equal to 4. and we'll factor out these two terms by x squared, which means this will become a plus c. We'll factor these two terms by x. This will become b minus 2a, and this will become 2b. And since on the left side only 4 is left, we can assume that we can write it as, there's the cursor. We can rewrite it as a plus c is equal to 0. Since the x is already missing, we can assume that this whole term is equal to 0. And the same for this x times b minus 2a. So I'll put 2a here plus b equals to 0. However, negative 2b will be equal to 4. Since we already have the value of negative 2b, the last one only has one variable. We can just write here negative 2b equals 4. We can divide both sides by negative 2. Cancel here. And we have our first value, which is equal to negative 2. Next, we can substitute the value v here to our second equation, which means this will become negative 2a minus negative 2, or minus 2 is equal to 0. We'll just transpose negative 2a. This will become negative 2 is equal to 2a, and divide both sides by 2. This one will cancel, and our letter a is equal to negative 1. Now that we have the value for letter a, we can substitute it to our first equation, which means this will become negative 1 plus c equals 0. And letter c will become 1. And now that we have the value for a, b, and c, we can just substitute it to the function earlier, which means that the partial fraction decomposition of x squared x times x minus 2 is equal to negative 1 over x minus negative 2 over x squared plus 1 over x minus 2. Or I like to put the positive terms first. So I wrote it like this: minus 1 over x minus 2 over x squared. Now remember that this function is still equal to our original function, which means that when we integrate this one, we'll still get the same value, like that. So we'll just integrate this term or this function, this is dx. And now that we use the partial fraction decomposition, it will become much easier to solve for its value. Now, for the first term, we can easily discern that since these two terms actually is just the integral of du over u is equal to ln u plus c. So for the first term, our u will become x minus 2. So we can write here that this will become ln of x minus 2, 5 to 3, minus ln, our u for the second term is x, ln x, then 5 to 3, plus this one, 2 over x squared, is equal to 2 negative 2, which means that when we integrate it, it will become 2 times x minus 1 over -1. Which means that our last term will become positive 2 over x, since negative times positive will be equal to positive. And now that we've integrated the formula, we can just substitute the following values, which is 5 as the upper limit and 3 as the lower limit. So this one will become ln of 5 minus 2 minus ln of 3 minus 1, or 3 minus 2, minus ln of 5 minus ln of 3 plus 2 over 5 minus 2 over 3. This one will become ln of 3 minus ln of 1 minus ln of 5, since minus negative ln of 3, so this will become positive ln of 3, plus this will become negative 4 over 15. And we can just rewrite this. We can just combine like terms, which this is ln of 3, we have another ln of 3. We can write it as 2 ln of 3. Ln of 1 is actually equal to 0, so we can just cancel that. Right, ln of 5 here, minus 4 over 15. And this is our answer for our problem number 3. So let's now proceed with problem number 4. This is another definite integral. Our upper limit for this one is 8 and the lower limit is 1. So we have to find the integral of the cube root of x plus 4. Now for this problem, we can actually use this algebraic substitution, in which we'll let z is equal to the cube root of x, and where x is equal to z cubed. Since if we raise both sides to 3, the cube root will cancel and this will become z cubed. So we can solve for the value of dx, and by general power rule, this will become 3z squared dz. And now that we have these values, this one and this one, we can easily substitute it to the original function. So this will become 8 from 1 to 8. The value of dx is 3z squared dz. And this will become z plus 4. Now we notice that the exponent of the numerator is 2 and the exponent of the denominator is 1. And by rule, if the exponent of the numerator is higher than the denominator, we have to do the long division, which is like this. So we have 3z squared divided by z plus 4. So 3z squared divided by z is 3z. Just multiply it here, 3z squared. This will become minus, this is 12z plus 12z. And since this will become negative, and we can divide it by z again. So become minus 12. Multiply it again here. This is minus. This will be equal, and we actually need to multiply this here first. Negative 12 plus 4 to 4. This will become negative 48. This will cancel, and negative 48 will change sign to 48. And since 48 does not have a variable, we can now stop there. So we have to write the integral 81. This will now become 3z squared minus 12 plus 48 over z plus 4. When we write it like that, it will become easier to integrate. Now, before we can do the definite integral, we have to integrate these terms first. So 3z squared, that will just become 3 times or no, 3z. This is only 3z. Sorry. 3z. This will become 3z squared over 2, then 8 to 1, minus 12z, 8 to 1, plus this term, we have to integrate it separately. So let's write here the integral of 48 over z plus 4. 4. Or actually, we can take out 48, put it here. So become 1 over dc. Now for the first two, we just use the general power rule to solve the integral. However, here we have to use ln, since this is in the form of in the integral of du over u. Our u is equal to z plus 4, which means our du is equal to dz, which means that this one is equal to ln u plus c, which means our integral for the last term will become the ln of z plus 4. So let's write here ln of z plus 4. Now this is not our final answer, since remember that this is a definite integral, and our values are still represented by z, which means we have to substitute the value of z, and in which we wrote earlier, our z is equal to the cube root of x. So we can just substitute it to it here. We have 3 times the cube root of x squared over 2. So become 8 to 1 plus or minus 12 times the cube root of x, 8 to 1. Then I'll write down here the ln of cube root of x plus 4, 8 to 1. Now, for definite integrals, we just have to substitute the values of 8n, multiply it with the value substituted by 1. So for the first term, this will become 3 times the cube root of 8, then squared over 2, minus 3 cube root of 1 squared over 2. For the second term, we have 12 times the cube root of 8 minus the cube root of 1. Then for the last term, we have 48 times quantity ln. This is cube root of 8 plus 4 minus ln cube root of 1 plus 4. Now remember that 2 cube is equal to 8, which means for this one, this is actually equal to 3 times the cube root of 8, which is equal to 2, and 2 squared is equal to 4. So 3 times 4 is equal to 3 times 4 is equal to 12. But I won't divide it by 2 yet, since we have to subtract it from this value, which is 3. The cube root of 1 is 1. 1 squared is still 1. So it becomes 3 over 2. This one, the cube root of 8 is 2 minus the cube root of 1 is 1. And plus 48. This now will become 6 since 2 plus 4 is 6. And minus ln of 5. We can just combine the like terms here. This will become negative 9 over 2 minus 12 plus 48 ln of 6 minus ln of 5. And now we can just combine these two. So I'll just rewrite it like this. 48 times quantity ln of 6 minus ln of 5. Minus 15 over 2. And this is our answer for the fourth problem. And moving on to the last problem, we have a slightly easier one. So fifth problem is we have to evaluate the integral of 8 arc tan 2y dy. Now we can already take out 8 as a constant there. We'll be left with arc tan 2y dy. Now for this one, we'll be using the integration by parts, which is represented, as I said earlier, by the integral of u dv is equal to uv, which is uv, minus the integral of v du. So first we have to identify which is u and which is v. For this one, our u is easily arctan 2y. This is u. Write it so you don't get confused. And our du will be 1 over 1 plus 2y quantity squared multiplied by 2 dy. Or let me rewrite it like this. 2 dy over 1 plus 4y squared. And our letter v will be equal to, or our dv is equal to dy. And when we integrate both sides, we'll get v is equal to y. Now we can just substitute these values here. Our u is equal to arctan 2y. Or let me write it down here so we'll have more space. Our u is arctan Forgot to write the 8. To write the 8 here, then quantity. Then UV, we have 8 here. Our U is equal to arctan 2y times V, which is equal to y. So I'll just write letter y here. Minus the integral of V. Our V is y. And our du is 2 dy 1 plus 4y squared. So we can write this term like this. We can put 2 outside. It's quantity plus c. We can put 2 outside, which means this is now the 2 integral of y dy over 1 plus 4y squared. I'll just rewrite it like this. 8y arctan 2y plus c. Now we still have to integrate the second term, in which we'll be utilizing this formula again, du over u plus c. So our u is 1 plus 4y squared, and our du will be equal to 8y dy. Now we'll notice that this term is missing an 8 here, so we can write 8 over here. And this one we multiply by 1 over 8, so it just cancels out. Which means that now we can get our final answer for here. So if we multiply 8 here, so become 8y arctan 2y. Then this will cancel, this will become 1, and this will become 4. And if we also if we multiply 1 over 4 to 8, 8 will just be divided to 4, which is equal to 2. And the integral here is ln. The value of our u is 1 plus 4y squared quantity plus the constant. And that is how we get our last problem. And since we're done with the fifth problem, once again, this is Harris from Syntax, paving your way to excellence.